Okay, hope you guys are doing well. What I'm going to do now is just kind of go through and review the topics in Unit 5 so that you guys have that to go over and look at. So it's kind of separated by each topic and a little example for each one. So you can go through and look at that. You should have this document linked as well. So if you want to write on there, you're welcome to. Or if you want to take your own notes, that's fine as well. But we'll go ahead and start on topic 1, which is parallel and perpendicular lines. So a few notes at the top. So parallel lines have the same slope, and perpendicular lines have opposite or negative and reciprocal slopes. So for example, if one had a slope of 1/2, the other line would have a slope of -2. Okay, they have opposite signs. Okay, and this is 1/2, and that's technically 2/1. So opposite signs and reciprocals or flipped. So number 1 asks us, are the following lines parallel, perpendicular, or neither? So we need to compare their slopes. But before you do that, you always want to make sure you're in slope-intercept form, or y equals mx plus b. That way you can actually see what the slope is. So the first line has a slope of 2. Okay, that's in slope-intercept form. This line, we need to solve for y, right, to get into that slope-intercept form there. Okay, so move the x's over. So do the opposite. We'll add 4x to cancel that out. So we get 2y equals not 4x plus 16. And then to solve for y, we'll divide by 2. So we get y equals 2x plus 8. Okay, so the slope of this line is also 2. So since this line has a slope of 2, this one also has a slope of 2. That means these are parallel because they have the same slope and different y-intercepts. That just makes sure they're not the exact same line. Okay, so that's one type of question. So you just compare their slopes to see if they're the same or if they're opposite and reciprocal. Number 2 asks us to find the equation of a line that's perpendicular to this line and passes through the point -2, 9. So if it were to say parallel, you would just keep the exact same slope and work from there. But then since this one says perpendicular, we have to find our new slope, which will be opposite and reciprocal of this one. So this slope is 1/2. Okay, that's positive, so we're going to make the new one negative. And then if we do the reciprocal of that, that's going to be 2/1 or 2. Okay, so our equation is going to equal, or it's going to look like y equals -2x plus something. And our job is to use this point to help us find that y-intercept. So -2 is my x, 9 is my y. So we can substitute those in. So 9 equals -2 times -2 plus b. So this gives me +4. Okay. And then if we subtract 4, that will give us b equals +5. And so our final answer would be y equals, we use our new slope, so -2x, and then plus the b that we just found, which is +5. Okay, make sure you don't use this b value. That's just a different line. We don't need it for our new line. We just use that equation to either use, if it says parallel, we would keep the slope the same. If it says perpendicular, we do opposite and reciprocal. Okay, so those are some quick examples there. So topic 2 is on distance, and it just depends on what they're giving you. If they're giving you coordinates and asking you to find the distance, you want to use the distance formula. If it was a graph, it may be easier to use Pythagorean theorem, which we'll see a little bit of down here as well. Okay, but this example, we're going to use the formula just because we'll do Pythagorean theorem down here. So find the distance, okay, between the 2 points. So we'll use distance formula. So we'll do square root. Okay, x2 minus x1. That means the second x minus the first x, which isn't going to matter too much, but 8 minus 1 squared. Okay, those are my x's. Plus y2 minus y1 squared. So we need to use our 2 y values. That's -10 minus -5 squared. Okay, so you can write it like this, or you can go ahead and say, oh, hey, that's minus a negative, which is the same thing as negative 10 plus 5. You could write it like that as well. Okay, so now our job is just to figure out what this is. So this gives me 8 minus 1 is 7. 7 squared is 49. Okay, that's going to be negative 10 plus 5, which is negative 5. And negative 5 squared is 25. And if we add those together, that gives me square root of 74, okay, which is, let's see, 8 point something. I don't have my calculator with me, but you can use your calculator to get that decimal as well, or simplify your radical. So distance, make sure you use distance formula. Okay. Our next topic was area and perimeter. So I kind of recapped the area formulas. We pretty much did triangles and then rectangles or squares. So triangle, you do 1/2 the base times the height. The rectangle, you do the base times the height. And then for perimeter, you always add all the sides together. Okay. So this one tells me this is a square. So I need to find the lengths of my sides, and then I can use that to get my perimeter and area. So this is a point where this is on the graph. You can use distance formula, but it's going to be a lot easier if you just make yourself a little right triangle. And then you can use Pythagorean theorem to solve for your hypotenuse, which is going to be AF right there. Could have picked any side you wanted to start, but I just chose that one because it was first. Okay, so this side is 3. This side is also 3. So we do 3 squared plus 3 squared equals x squared. Okay, so 9 plus 9 is 18. And then we need to do square root of 18, okay, which is, let's see, about 4.1. I think it's 4.2. Okay, so we'll use that as our side length. And since this was a square, and that's why I'm going ahead to fill all these in, all of these values are going to be the same. So you don't have to redo the same thing for each of them, because if you make your right triangle, you'll notice this is 3, this is 3. Okay, it's going to be the exact same answer. Let me go grab my calculator real quick. Sorry about that. Now we're going to find our perimeter. So we want to add all those sides together. So 4.2 plus 4.2. Okay, add all those together. And that gives you 16.8. Okay, and then area, we do base times height or length times width. You want to multiply those sides together. So 4.2 times 4.2. And that gives you 17.64. Okay? So depending on what the shape is, if it's a rectangle, you would have to find both sides. But since this one said it was a square, we could just do one side and we knew they were all the same. All right, so those are our first 3 topics. We got a few more to work through here. Okay, so topic 4 was on partitioning. We only did 1 day of this, so if you were out, you may need this to try to catch up and know what's going on when I ask you these questions. Oh. Okay, so partitioning means like breaking your segment into different parts. So you have these 2 formulas to help you out over here on the side. We're going to use this one. Okay, just because it's a little bit easier and it kind of makes sense to what it means. It looks really long, but basically you do the x values as one part and you do the y values as another part. So in the problem, they're going to give you a specific ratio that you want to separate it into. Okay, so that's going to represent your A and your B. And then they're going to give you 2 coordinates, your starting coordinate and your ending coordinate. And the order does matter here when you work these out. Okay, So it says find the point P that partitions line segment AB in a ratio of 1 to 2. Okay, so that's going to be your A and your B, where A and B have the following coordinates, and A is -2, 6, and B is 1, 12. Okay, so the first part of the formula, I'm going to go ahead and write that down. And then we're just going to fill in everything we know based on what goes where. Okay, so x1 is my first x, which is the -2. Okay, this a over a plus b is your ratio turned into a fraction. So the 1 is your a value that goes on top. Your denominator is 1 plus 2, so that gives me 3. Okay, that tells you how many parts there are altogether. And then my second part of my formula, I'm going to do x2 minus x1. So second x minus the first x. So 1 minus -2, which is going to turn into 1 plus 2. Okay, so that gives me -2 plus 1/3 times 3. That's -2 plus 1, or -1. Okay, that is my x coordinate. So now we're going to do the same thing with our y coordinate. And I'll write down that part. Okay, so now we're using the y values. I'm going to circle those so I don't get mixed up and go back to my x's. So y1 is my first y, which is 6. Okay, this a over a plus b is that same fraction I got right there, so 1/3. And then y2, so my second y minus my first y. So 12 minus 6. So that's going to be 6 plus 1/3 times 6, which is 2. So 6 plus 2 gives me 8. Okay, so this is our x, this is our y, and then our final answer will be as a coordinate. So -1, 8. Okay, and so if you're get stuck there, just kind of go through, label x1, x2, y1, y2, and then remember the a over a plus b, that comes from the ratio. A comes first, b is the second number. Okay, so that was partitioning. If you need to write that down or you need to write that formula down, that will help when you're doing your practice. Okay, our next topic was midpoint. And that didn't show up too brightly on here, but our midpoint formula is x1 plus x2 divided by 2, and then y1 plus y2 divided by 2. So we kind of had two different problems, one where they just ask you to find the midpoint, and then one where you're looking for another endpoint. So if I want to find the midpoint using the coordinates, we find the average of the x's. So we add the x's and divide by 2. So 2 plus -6 divided by 2. So that gives me -4 divided by 2, or -2. And then we do the same thing with our y values. 8 plus 4 divided by 2. So that gives me 12 over 2, or 6. Okay, and then same thing like with partitioning, we write that as a coordinate. So it'd be -2, 6. Your x and then your y. Okay, now number 7, you're given a little bit different information. It says, given the midpoint and the endpoint, find the other endpoint. So they're giving you the middle and they're giving you an endpoint. Your job is to figure out what is the other endpoint. So you kind of have to work a little bit backwards here. And you can think about what, if this is in the middle, what would be on the other side. I know I talked through that a little bit, but I'm going to show the algebra on here if you want to do it that way. Okay, so the midpoint is basically what you're going to be equal to. I'm going to do my x's on one side and my y's on the other. So they give us 1x is -6. Okay, we don't know the other x because that's going to be from the other endpoint. Okay, so that's going to be what I'm looking for. So -6 plus something divided by 2 should give me -4. Okay, think about the midpoint as your answer. That's what we get out. So this is what we need to solve for x. So multiply by 2 on both sides to cancel that out. So we get -6 plus x equals -8. Okay, and then add 6 on both sides. So we get x equals -2. Okay, so that's going to be my x coordinate of my endpoint. And now we'll do the same thing with our y's. Okay, we know one endpoint is 1. We don't know the other one. So I'm going to just do 1 plus y divided by 2. And we know our answer should be 6 because that's my y value of my midpoint. And we'll solve it the same way we did this. So times 2. So 1 plus y equals 12. And then subtract 1. And we get y equals 11. So that will be the y value of my endpoint. So -2, 11. Okay. And if you think about it, okay, the midpoint should be in the middle of those values. So compare your two endpoints. So -2 and -6. The middle of that is -4. Okay. With 1 and 11, the middle of that is going to be 6 because that's 5 away from 1 and that's also 5 away from 11. So you should be able to look back and say, okay, is that actually in the middle or did I mess up somewhere? Or you can even think through it that way as well. Okay. And then our last one is on classifying shapes. So it's basically just using all the information you have to be able to tell, what type of triangle it is or what type of quadrilateral it is. So I didn't do a triangle, but just to make sure, if you want to classify your triangle, you need to find the lengths of the sides. So doing Pythagorean theorem, equilateral is all sides congruent, isosceles is 2 sides congruent, and scalene is if they're all different. If you want to show it's a right triangle, okay, you actually have to find the slopes and show that those are perpendicular. So they have to have opposite and reciprocal slopes. Okay, so these you use the Pythagorean theorem with the side lengths. Right triangle, you have to use your slope and do rise over run. Okay, for any quadrilateral, you basically want to do both of those things, find the slopes and find the lengths. And then from there, you should be able to use your definitions to tell what type of figure it is. So we've got 4 sides, and this is the same one I had on the other side to save us some time. But let's do our slopes first. So remember, slope is rise over run. Okay, so the slope of AF, I will go up 1, 2, 3, and over 1, 2, 3. So 3 over 3, and I went up and right, so that's positive. And we want to simplify. 3 divided by 3 is 1. Okay, FT, this one's going down, so I know I'm going to have a negative. So down 1, 2, 3, and right 1, 2, 3. So -3 over 3, which gives me -1. Okay, TZ, this one's going up. So 1, 2, 3, 1, 2, 3. So 3 over 3 is +1. And then AZ, this one's going down. So that's going to be negative. So down 1, 2, 3, right 3. So that also gives me -1. Okay, so if you notice, these have the same slope, AF and TZ. And these have the same slope, AZ and FC. Okay, so that means opposite sides are parallel. Okay, and that really should happen, especially if you're classifying a parallelogram. You can look and see those are parallel, these are parallel. Okay, this one's a little bit tricky with perpendicular, but you want to see if they're opposite and reciprocals. So the ones next to each other, which are called adjacent. So these are opposite signs. One's positive, one's negative, and they are reciprocals. They just happen to be 1 over 1. And then if you flip it, you still get 1 over 1. So these are perpendicular. Okay, same thing here. So we would say adjacent sides are perpendicular, which means you're going to have right angles. Okay, if they're not perpendicular, then it does not have right angles. So it couldn't be a square or a rectangle. Okay. So from here, we know it has right angles, and we know that the opposite sides are parallel. Okay, the distances are going to help us see, okay, is this actually a square, or is it just a rectangle that looks kind of close to a square? And if it didn't have right angles, then it couldn't be a square either. Okay, so for the distances, that's where you use Pythagorean theorem. And this is the same one we did on the other side. So make your little right triangle, 3 and 3. So 3 squared plus 3 squared equals x squared. So 9 plus 9 is 18, which gives you 4.2. Square root of 18 is 4.2. And then if you test all these, okay, that triangle is the same size, so I'm going to get the same thing. Okay, that triangle is the same size, I'll get the same thing. And this one as well, 1, 2, 3, 1, 2, 3. Okay, so all sides are congruent. Okay, so if it has right angles and all sides are congruent, that means it is a square. Okay, so if you get stuck on those, just find all your slopes, find all your distances, and you should be able to justify it. You should have a guess before you start. That looks pretty much like a square. You just had to check to make sure it wasn't also a rhombus. Okay, so use this to help you out as you're working. Hopefully that helps with some of those things we haven't done in a while, so we can review through Unit 5.